Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm Steve Marks.
This show this week is actually a special edition show, or I should say it's a rehabilitation show for Steve and I. We have been struggling with ways that we can cut down and efficiently use our verbiage and words to be more meaningful.
I like how you made that the longest sentence possible.
I know. This is why we're working on it.
Exactly.
So we got some feedback. Folks said, well, you use the words cool and awesome and sweet and
Radical.
Yeah, rad, a lot. And you probably use it more than you even know. So what we thought we would do this show is we would actually treat those like, you know, the four-letter words that they should be. We would have our editor censor them out.
I'm not sure radical is a four-letter word.
No, but it's treated like a...
Okay.
And it's rad, by the way.
So we're going to bleep them out.
Yeah, from this point on in the show, every time you hear us say these, I would say filler words like or cool, you're going to hear a beep. So don't be surprised.
Yep.
All right,
It's
Steve.
just to help us.
Yes, it's to help us.
If this doesn't work, we're going to get electric shocks next time.
Yep.
We're just going to have Mike in the back just hit a button every time we say the wrong word.
Exactly.
Yeah. So anyway, so that's what's special about the show.
Let's talk about what we're going to cover on the show.
Okay.
The feature this week is going to be Steve dancing.
Yep.
Or no, actually, Steve is swingifying applications in Windows Azure, or I should say songs in Windows Azure, songs in Windows Azure, and he's going to take that and show you how he did that using Python.
Yep.
Right?
Yep. That's the feature. And we're going to, of course, cover some news, and then we're going to wrap up with a tip of the week that actually comes from my experience debugging this application that I'm going to show. And so I'll give a little hint, a little tip about how to do that. But let's start with the news.
Yep.
Ryan, you want to talk about this one?
Yes, the Patterns and Practices team, led by the amazing Eugenio Pache, has again released the second part, or the beginning of the second part of their Windows Azure guidance. So it'll be Windows Azure Guidance Part 2. And in this scenario, instead of Part 1 was focused on migrating applications to the cloud, in Part 2, they're actually going to be focusing on kind of the ideal cloud scenario. So if I could just build this from the beginning, how would I optimize it for the cloud? Now he has a series...
Greenfield, if you will.
Greenfield, right. So he's going through and he's explaining in this particular post the authentication and authorization model that they're going to be showing in this particular guidance this time, and he's diagramming it out in the Eugenio style. And as you follow along with this, you're going to see some of the best ideas that we have, or some of the guidance that we're going to be delivering at the end of this process on how you can architect your applications from the beginning to take best advantage of the cloud. Now, this is something I ran across in the blogospheres, so to say. MongoDB these days is the rage. All the kids are using it. And
I think you just said a four-letter word. I think that might be our first bleep.
I think there might have been other ones.
That's possible.
I think I said Eugenio was great.
That's probably true.
Anyhow.
He is really
Anyhow, the MongoDB, for those of you who are not familiar with it, is one of the NoSQL kids that is an entity attribute value store. And in this particular post, you can actually run MongoDB in Windows Azure Worker Role. And what we have here is some code and just some kind of setup on how you can get that running yourself. Now, Steve and I were looking at this a little bit, and we said, yeah, you know, this is one way you can do it. There's a few deficiencies you think about in this model because, for instance, I think this is running on a single instance. So you kind of have a scalability, or I should say a reliability bottleneck here.
Yeah, that was the one. The one part we were kind of looking at before was actually this code at the bottom, where we're basically grabbing the first instance of the worker role and connecting to that as the MongoDB endpoint.
Yeah,
and that may not be the architecture you want in the case of worker roles coming and going, and so it may be okay for your application to have one worker instance be that MongoDB endpoint, but you want to make sure it's the right one and that failover can actually happen, and that you're finding that. So So maybe we should actually cover something about that pattern in the future. Let's
Yeah.
say 6 months from now, so we don't actually have to do it.
Well, the other things I don't think this post takes into account are if that node goes away, for instance, the data store that MongoDB is using is not available to the other instances as far as I can tell. There's no replication.
Actually, wasn't it drives,
or
though?
sync.
I think it was using a Windows Azure drive, so I think
Well, if he does use a drive, then that would be...
you could go mount it again on the other
mount
one.
it again.
But I didn't see code that actually handles that failover. Now someone else
Right.
mounted and whatever. So there's probably more work to do, but that's not to take away from this. It's actually really cool to see this working and covers kind of what do you have to do. What's the I guess it's Xcopy deployable
Right.
and sort of works, but configuring it to point to the right location, figuring out the endpoint to listen on to actually get it started. Similar to some of the stuff we've covered here, but it's good to see because for some reason MongoDB has come up. It's not MongoDB itself isn't new, but it's come up in the context of Windows Azure like 5 times in the past week or so. So people are clearly interested in doing this. So this should get you started. It's really to see this.
Yeah, it looks pretty cool. All right, so session tracing. The SQL Azure team has put together a blog post on session ID tracing. This is something that I didn't know, and it's one of those cool little tips that you find floating around the inner tubes. And basically, there is a way that you can retrieve the session ID for a particular request, and it's documented in here. And once you grab that ID, you can then use that for troubleshooting later. So this is just one of those tips. If you ever get into a situation where you're trying to diagnose what happens and you need that particular trace, you want to identify the particular request, that trace ID is there and you can deliver it. And especially it's handy if you ever had to call up support for any reason. You can supply them with the trace ID and they can look it up in the logs. So just a handy tip to know.
Is handy one of the words we're allowed to say?
I don't know.
Handy's
We'll
kinda
find out after we
borderline.
watch the show how bad we're doing.
Bob's discretion, our editor. The last thing we've got here for the news today is on the Windows Azure blog. It's a blog post called, and pretty self-explanatory, "We want to showcase your building block solutions for Windows Azure." This is actually coming from Ashish, who's a senior product manager on Windows Azure, and he basically wants you to email him if you have what we're calling a building block component or service.
What is that, Steve?
That is, I'm glad you asked, Ryan. Building block components and services are designed to be incorporated by other developers into their applications. So the example that we gave in this blog post is if you've got like a billing engine and you want your end users, you want me to be able to give my end users sort of a billing experience on top of my thing. I can go build an app that uses Ryan's billing service and makes my application better. So it's services that are designed for developers to use, and developers kind of put them together with their app. So
like SQL Azure would be a great building block.
SQL Azure is a building. That's exactly right. I would consider SQL Azure a building block component. So if anyone on the SQL Azure team is listening, please email us. Let us know what you're doing. But UI controls, management tools. Those are also some of the tools we've shown here.
Logging.
MyAzureStorage.com could definitely show up on here.
Yeah, if I let developers integrate that into their applications.
No, we're considering it anyway. I don't know. Yeah. If developers use it, right? If it helps me to build my app by using that, we're actually counting that. So if you've got tools or something else, I mean, tools can count libraries or services that are consumed by other people. All those things are good. If in doubt, send us an email, and we'll just throw it out if we don't like it. But we'd like to get in touch with people who are doing this and learn what people are doing and help to give a little advertising, shall we say, for people who are doing this. So certainly if you're doing it commercially and you're looking for an opportunity to get the Windows Azure team to look at it and to talk about it, this is a good way to do it.
Right.
So that's a perfect segue, I think, into
your building block app that you just built.
It's not a building block app. This is actually a horrible segue.
This is the UI to it, right?
This is the UI to it. Come on. Let's listen to. Should we do the comparison version of this?
Yeah.
I don't know how to explain this except to just let people hear what this is about. So I'm gonna just open it up. Let's find one of Ryan's favorite songs.
Oh my gosh, I love this song. Seriously, my favorite version too.
It is. It's better than the original, I think. So. This is Cartman from South Park singing Lady Gaga's song Poker Face. Now what I've done is I've gone up to swingify.cloudapp.net and I've uploaded that MP3, and this is the result.
Wow.
A little different feel.
A little jazzier.
Little swing. Kind of makes you want to dance. I think we should just pause for a moment and just listen to the song for a while, because it's fantastic.
Oh, yeah.
It's pretty good. It's a very kind of sing-songy sort of thing. Okay, we could play more of it later, but we should probably talk a little bit about the app.
So how did you do this, Steve?
Well, the first thing is, I didn't actually do any of the hard part about this. So
You mean you didn't sing the song?
I didn't sing the song. That was indeed the hard part. But if you go read this How It Works thing on the page, it's actually this app that I saw on TechMeme, on techmeme.com on Sunday, I believe. So by the time everybody watches this, that'll be almost a week ago. This showed up as basically a little Python script that does this, and here's the original blog post that talks about it, and actually links off to the Python code that does this. It's using an API by the folks at EchoNest. So it's a developer API from EchoNest. I signed up, got a key, got the Python code, made a couple tweaks actually, because it didn't seem to work out of the box on Windows, because it's trying to name some files in ways that are illegal on Windows. So I had to tweak it a little bit, but mostly just ran it, got it running locally. I just think it's weirdly cool to take any song and just turn it into this like sort of swing time. Maybe we'll play something else too later in the show. But I thought it was really cool. So I thought the thing is, it's kind of hard to get going, because you need Python. You need the two different APIs actually from the EchoNest folks, some different libraries for Python. I had to tweak the code a little bit to get it to work on Windows. I don't know if I was just doing something wrong or if that was really necessary.
And you just wanted an excuse to get Python running in Windows Azure.
That too.
This is not Iron Python. This is Python.
So this is Python. So anyway, so I decided to put it up as, so anybody can go to swingandfly.cloudapp.net, upload an MP3. You've got, it takes a few minutes actually, but it'll come back and you can listen to an MP3 of it.
If you get some songs after this airs, if you guys try this,
please tell us.
Tweet them. I would love to hear your best ones.
Whatever comes. Some of them come out really bad. There's some disasters that come out here where it just doesn't work. But if you find one that just really works, do please let us know.
We're talking like, Poker Face by Cartman is just.
Yeah.
And if you can find something that tops that, like
my bar is actually a lot lower. If you have something half as good, I'll listen to it. Let's talk about, let me actually go to the whiteboard and I'll just go through kind of how the app itself is designed.
Okay.
And then we can go, I don't know, we can go look at the code. I just wanted to show this to everybody. I don't really, there's no point to this feature. It's just an example.
I would say the point is to show people how to get Python running and to give them an architecture that could do it.
Yeah. So there are actually a couple interesting, I say there's no point here, but there are a couple interesting technology things that are happening here. The basic architecture of the app should look pretty familiar. It's a web role and a worker role. So exactly two roles. This worker is scaled out a lot more. There are a bunch more instances of the worker because it's the thing that does the actual MP3 transformation, and that actually takes a couple minutes of like solid sort of CPU time. So this I've scaled out to meet the high demand I anticipate. And in between them is a queue, like we often do. That basically, so the web is some MVC code. It handles the MP3 upload, stores it off to blob storage to a container called incoming. So it stores it at like incoming / some GUID .mp3. Actually, I don't think I even put the .mp3 on it. Something like that, and then it puts a message on the queue that just says that GUID. Okay, so pretty standard. So MVC code handles the file upload, stores the file itself in a blob, puts a message on the queue that references the blob. And this is a pretty standard pattern for if you've got a lot of data that you want to transmit from one thing to the other. So you want to use the queue for reliability, but you need more space than the queue allows, because each queue message can only be 8 kilobytes. 8 kilobytes. So for an MP3, you certainly need to go put that out. So put that off in blob storage. Put a message here. The worker role is some C# code that mounts a Windows Azure drive, and in that Windows Azure drive is Python with those libraries that I mentioned, with the libraries from Echo Nest, also a small little DLL that does the actual time expansion and compression, that does this. The swing thing works by basically taking each beat and making the first half of it actually take 2/3 and make the last half of it shrink down to 1/3. So it kind of takes each beat and kind of skews it like this, and it gives it that swingy feeling. So there's a little DLL that's required for that. That's in here with the Python runtime and with all the libraries that are involved in this. And the C# code basically pulls a message off the queue, downloads the blob to local storage, so it saves it just locally on the disk, runs Python pointing it at that, runs the this little swinger.py. Not that any of you can read that, but it runs swinger.py and points it at that MP3 at the local one that it copied. When the whole thing is done, it saves out the result as output/GUID. So it basically takes that from the local disk. So Python operates on that local disk, and then it sends it back out. So there are actually like a couple things going on in that worker. I mean, there's the .NET code that handles the queue stuff, that dequeues the message, deletes the message, also does file download and file upload with the results. So it's sort of a harness around this. And then the Python code is running on a Windows Azure drive, which is mounted as a snapshot, and so it's read-only, and that way all the worker instances can mount that same drive. And then there's local storage that's actually temporary. That's where we store the MP3 and then we store the output before we ship it off again. And so at the end of this C# code, at the end of each of these loops, at each message, just deletes that whole directory of everything that's in that temp directory. Then in that MVC code, there's a little bit of AJAX stuff going on that basically polls to check if this file exists. So it just keeps checking blob storage and if through the MVC role. So it sort of calls a method here that checks. And if that output exists, it replaces it with that little Silverlight-based MP3 player. If it doesn't exist, it just puts a processing, a little sort of progress indicator thing there. So that's basically it. That's the technology.
Why did you use Windows Azure drives as opposed to, say, packaging all of that Python stuff in each Windows worker role?
There's no good reason, I think. The main reason, there is a reason, and the main reason was that way I could change the rest of that worker code without having to upload. I didn't want every time I deploy this thing to have this huge package. And Python's not actually that big, but it's 70 megabytes or so with the stuff that I need. I didn't want that to be part of the base package because then I've got to upload that whole thing every time.
Right.
And so it's kind of a I thought that that's going to rev a lot less. If I did this over, one thing that I would change in the way I did this is that I would not put that Python script, swinger.py, I would not put that in the drive. Because that's the part that's that's sort of my code, right? There's a bunch of stuff that's just Python and some libraries, and that's almost never going to change. But then there's a little bit that's my code, and actually at one point, I wanted to make a change to capture the title and the artist.
Yeah.
And in the Python code, it's very easy to sort of emit that. And in the C# code, it was very easy to make that metadata on the blob. That's what I ended up doing, is just storing it as custom metadata on the blob. But I had to change both of those things, which meant I had to go change the drive and upload it, get a new snapshot ID, then change my C# code, and then deploy a whole new version that had the new .NET, harness and the new snapshot URL. And it was just a little bit I think it would probably be better to just say, okay, this is just Python over here, and then all my code goes in the package, and that way I can handle rolling upgrades, and I can do all that goodness about deployment on the stuff that's really my code.
Right.
So that's kind of why I did it that way, why I split it out into drives, but I think I did it wrong. So to be honest, I would put that Python code with the C#, where I did do it again. Should we look at the code at all? I mean, there's a.
I think that would be great.
There are a couple things to. Let's just look at that worker role, because that's really the main loop. And let me increase the font here and go full screen. So on start is here. Setting up diagnostics, initializing the cache. This is exactly like what we did on the drives episode that we just did.
Was that 2 weeks ago or last week?
I don't know anymore. I can't keep track of these things. I think it was 2 weeks ago.
2 weeks
I think
ago.
it was 2 weeks ago. This actually mounts the drive, and so it's using a configuration setting that says the snapshot URL. Again, this is exactly like what I did when we covered drives before, and that's about it. It mounts this drive. You can see my sort of ugly error handling here. I've actually blogged about this. This is my printf style debugging, where I just catch the exception and just stick it in a blob called error or something. It's handy when you're debugging. That's all I can say. Okay,
This looks like a production quality.
Production quality for sure. That's why I've gone ahead and shipped it to the internet. So that actually mounts the drive. So the drive, remember, has the Python code, library Python, or whatever. In the run method, I get a reference to this queue, create it if it's not already there, and then forever, get a message. I use a time span, I use a timeout of 5 minutes, so an invisibility timeout of 5 minutes, because this actually takes that long.
You got to process the file.
Usually only takes 1 to 2 minutes, but I did have times, depending on the size of the MP3 or the length of the song, sometimes it would actually time
So
out.
like if you uploaded Stairway to Heaven, for instance,
Exactly,
it could
Stairway
take,
to Heaven.
it could take 5 minutes.
Precisely. So I went ahead and just put 5 minutes, because I thought you want to be careful about this. You want to make it long enough that you don't end up reprocessing the same file over and over again, because you can't do it fast enough. But you also want to make it short enough that if something goes wrong, you actually pick this up again. Because there's somebody staring at a blank screen that says processing, waiting for that thing to come up. You don't want to, if you have to retry it, you want to retry it as soon as soon as
So
you
one
can.
of the things you probably should do here is check that DQ count. And if you got like the same message 3 or 4 times,
That's a
you'd
good
be
point.
like, you know what, either there's an error in the processing script, right, like the file's actually corrupt and I can't process it, or maybe someone's uploaded like, you know, all of a symphony or something like that and wanted the whole thing swingified, and that
Done.
takes too long. Yeah.
It took less time to edit the code to do that than it took to explain it.
Well, we should explain it. The DQ count is important.
Yep, the DQ count, exactly. So, I mean, what Ryan was saying, if I've already looked at this message 5 times, just skip it. And so I'm actually just going to delete it. Now, a better way to deal with this is, and if I actually go edit this code, I'm probably going to go revisit this again. And a better way to do this
Put it
is
on another queue.
put it on another queue or persist it somewhere else. I happen to know that they're just strings with GUIDs. I could write them to a table or anything else. It doesn't really matter. But the point is, put it somewhere so that you see what caused your application to crash 5 times, and you can take a look at it and figure out if that's just because it wasn't actually an MP3 file that somebody uploaded, or I mean, if it's some expected case, or if it's something weird. No, this input for some reason is causing me to crash. So it's good for diagnostic reasons to do that. This will at least save me from the infinite loop, because the delete message is there. So if I haven't seen it 5 times already, I'd process it. If not, I still just delete it, and get rid of it. And then I've got this little thing. Do you do this? I tend to do this in my code. If I haven't gotten a message, I sleep for 5 seconds. Basically, so that if stuff is idle, I'm not just cranking around doing a whole bunch of transactions, because you actually charge per transaction of storage. And
if you have
the difference between
100 workers,
and all of them doing it as fast as they can, you can actually end up getting throttled by storage for this and whatever. So I tend to, if I got a message, then I just spent like 3 minutes processing. Go ahead and try to get the next one right away. But if I didn't get any message, then I wait for 5 seconds before pulling again. Some sort of exponential back off with a cap might be the best of everything, so that at night you really barely check the thing at all, but during the day you didn't make people wait too long by waiting for 5 seconds.
I'm gonna go with other apps. This would be a great pattern, but for Swingify, I mean, come on, this is Swingify.
Let's let it swing. Okay, this is the thing that does the work. We won't go through it in all the gory detail, but here's the key part: is I'm just creating a new process that points to python.exe. And passes in
name of the script.
the name of the script, and the quotes look kind of this way, but just a quoted path to the MP3 file. I'm setting a couple environment variables, like I'm setting path so that it actually has the Python, the DLLs, and everything in the path. I'm manually setting the temp directory, because this script happens to use the temp folder to do this, and I don't want to have to worry about how big is the temp directory and where is it and whatever. So I'm explicitly setting it to point to one of my local storage nodes, which I've said is a gigabyte or something like that, so that I know that I have space for that. So that's actually that's a decent tip there. And then I have to set this API key just for the Echo Nest APIs to work. If any output comes out, I just write it to log. So just do debug.writeline on it. Start the process, listen to all the output, wait for it to finish. When it's done, I find the output file, set the metadata with the title and the artist if they're available, and upload it. This was kind of cute, but probably a bad idea in the long run, is if it didn't work for whatever reason, I upload a blob with the exact same name as what we expect the output to be, but I make it a text file that says this failed.
So when you download
Before I put the Silverlight Media MP3 player, it was fine because you'd just click, oh, it's done, and you'd click on it, and it would just pop up and say, sorry, we couldn't do it. With the MP3 player, the MP3 player gives you an error, so it's not particularly good. But then if you click the download link, you actually see it. So another back channel that says, maybe metadata on the blob or something that says this failed, some way to sort of indicate back to the user or to whoever's waiting for this job to finish that it failed. That would be a good idea. You could even just use tables. A lot of people do that. They just create a table entity per job and put status in it.
And then your MVC app just reads the table.
And then you just read that. Yeah, exactly. And then this is, as I said, just cleaning up all those temp directory, all those files there. And that's pretty much it.
How long did this take you?
Longer than I care to admit, because I spent a good solid day debugging an issue with getting Python running in the cloud, and that's actually going to be our tip of the week. But can we listen to this a little more before that? I mean, this song it's just so good.
It's catchy. This is one of the sweetest renditions I've ever heard.
I mean, it was already good. Cartman doing it was good, but Cartman doing it in swing time, it's awesome. It's even better. Okay, I just can't help myself. Anyway, we'll link off to, I'm going to get a blog post out. By the time this episode is live, there should be a blog post on my blog. We'll link to that, and I'll have linked to all the greatest hits of, what I know of that's out there that sounds good. So you guys can go listen to this. So we should probably cover that tip that's really about debugging.
Now comes the time in every episode when we unleash the tip of the week.
Yeah.
This week's tip of the week has to be introduced because of the swingy theme. I can't think of anything swingier than boy bands of the early 90s.
Exactly. That's as swingy as it gets, I think.
Yeah, and I mean, or was this swingy or swingers? I forget.
Yeah. I don't know.
Anyhow, the tip of this week is going to be introduced, I think, by the boy bands of the early 90s, and I would like to see, Backstreet Boys or
New Kids on the Block.
NKYOTB. NKOTB. New Kids on the Block, right?
Yeah. New Kids on the Block. Nikatpa.
Backstreet Boys. NSYNC.
I don't know.
Oh, that would be awesome.
Whatever.
So anyhow, to introduce the tip of the week, boy band. Okay, Steve.
All right. With that intro, let's talk about the tip of the week. I don't actually have anything to show for this. This is something we should just talk about, which is I just beat my head against a wall getting Python running in the cloud. Because I did just like I do with PHP, for example, or actually MySQL, or we've done, we ran
Apache,
Mongoose, Apache.
Jetty,
I think
Tomcat.
MongoDB, Jetty, all these things have one thing in common, which is that if you just copy them to another machine, they work. I thought Python was that way.
Therein lies your failure.
Because you install Python, and it installs it all very cleanly in this nice, C:\Python 2.6 or whatever version you're on. It looks very nice. I copy it up to the cloud, and it didn't work. And basically what I was seeing as I was going to debug this and looking at the logs is I would start the Python process, nothing would happen, it would just sort of return right away. No output, no console output, no STD error output, no nothing.
No nothing.
Didn't crash anything or whatever because it was a separate process. You know, I was just doing process.start. So it's sort of like if you came to a computer and you just type Python, enter, and it just came back to command prompt.
Right.
Just at a loss as to what's going on. So I was spending time trying to figure this out, you know, debugging it against the cloud, just adding different kind of logging or whatever, trying to guess at the problem. I finally figured out how to debug it locally, and that's really what the tip is about. And what I did is I uninstalled Python. And then I mounted the drive that I've got that's got Python or whatever, and I just typed Python at the command prompt, and as we thought, it just came straight back to command prompt, nothing happened, except that a dialog box popped up and said, can't find Python 26.dll. Make sure Python is installed correctly or something. You know, this sort of message that basically said we were missing a DLL. Because it popped up as a dialog instead of being some output on the command line, I never saw it in the cloud. I never really had much of a shot of catching this in the cloud. And so the tip is really to test locally in as close a way as possible to what you have up in the cloud. Which means if you're worried about something like this is installed, uninstall it, or go to another machine and copy the stuff, whatever you're going to copy into the cloud, copy it over to another machine, try to run it. It's much easier to find and faster to kind of iterate on these things when you run it locally. The resolution of this problem was to reinstall Python, because I uninstalled it, go to Windows System 32, find Python 26.dll, and just copy it into that drive, into the Windows Azure drive that I had. Once there was a local copy there, Python actually worked fine. I don't know that that's the only DLL that any part of Python uses, but it was enough to run this. There is a project, which maybe we can link off to, called, I believe, Portable Python. It's actually someone maintaining a Python distribution that's built for sort of putting on a USB key and like
sounds
sort of
like
taking
a kind
around.
of a Python bad practice to copy things into System 32. Thought we told people to stop doing that around Windows 3.1 timeframe. Maybe Windows 95.
Don't know.
So,
yeah, I don't know if there's actually. I wonder if there's a reason for it, because it seems like the
it's
obvious
in
thing would be to do is just put it in this, and I fear it's not a very good reason, but it might be. And so a word of caution is that I haven't tested anything except this one app by doing this. So who knows what other sorts of things you'll run into by doing this. But that Portable Python project is probably a better route. That's actually, it looks like it's sort of tested. It lags behind the Python version a bit, but it looked like those guys were serious about maintaining this and doing this as something that they could really carry around on a flash drive. So that's the tip, is really, I mean, to be specific, for Python, make sure you got that DLL. But in general,
try it.
Just try to
locally,
debug locally as close as you can as to what's in the cloud. And I know that's sometimes hard because you have different modules installed, you have different things. When in doubt, copy everything off, uninstall, and run it, or copy it to a machine that doesn't have it installed. And that should help you to debug these things.
All right. Well, with that, this has hopefully been the coolest, most awesome, great, wonderful show you've ever seen. And we'll catch you next time.